thank you everyone for coming here. My name is Filip Babic. I'll talk about making a Kotlin, architecture components, RX, and coroutine sandwich. Sadly enough, I won't be handing over food. I'll just be talking about my experience. This is kind of a weird title, I guess. So more specifically, what I'll be talking about is modernizing Android, or rather using modern frameworks, modern functionality from Kotlin and Android to make a stable application, to have some things automized, which usually require a lot of boilerplate code. So I'll be talking about the project structure, more specifically how we create modules in our project and how we separate the code. I'll be talking about tackling the configuration changes. Yeah, that again. So it's still a thing in Android after all these years. And I'll kind of try to pitch you an idea of using functional programming paradigms to improve the data flow and data structuring in your entity layers. So the repository and that. So first off, project structure. Most of you started here with, or rather, I'll start with a question. So how many people here are Android developers? Okay, so that's a good bunch. Okay, so most of us started with single module projects. Is the easiest way to learn. You have one module, and all of the code goes into that module, and it kind of looks like this if you decompose it. What's wrong with this is, when I look at the single module project structure, you have all these dependencies. You have the API code which talks to the service. You have interaction layer, which is like a middleman between the business logic and the API. Then you have the view models or presentation layers to cover the business logic. Additionally, you have UI, which is the features or the user's code, so whatever the user sees. And when you look at this entire structure, a big problem arises. So there's a huge amount of heavy coupling. So everything here is heavy coupled. You can't really separate one thing from another. Everything knows about everything else. So for example, the app knows about everything. The API shouldn't know about the UI part, but it does. You can do some bad things in the API layer. You also have the dependency injection part, which kind of has to be here. It kind of has to start everything up. And of course, you have models and networking and so on. And all of this is heavy coupled in a way that, for example, if you have an Android application and you have a login screen, you decide at one point to remove the login screen. You kind of have to go through all these files. You have to find the login code, login specific code. For example, the UI part is activities or fragments. The view model part is the login view model. And also the models you use for the login, for example, the requests and the responses. And you have to go through all the packages, dig around, and delete those if you want to remove a module, which is kind of annoying. It's a nuisance. Furthermore, everything knows about about other things, and if you were to build something like an instant app or something like that, you can do this because it kind of requires of you to separate things away. The other thing about this is it kind of looks like this. So everything is mingled together. You cannot point anything anywhere. So if you're trying to find one thing, you're probably gonna end up in a ton of code in a large code base. And after a while, it piles up and it becomes a legacy project, right? So a better approach is the clean architecture. Oh, sorry, clean architecture-driven projects. So how many people use clean architecture here? So, okay, that's a good part. In Android, it kind of looks like this. So we have the app module, of course. You kind of have to have the app, but you also have data, device, and domain. So if you take the code from the app module, which is the entities, the networking layer, the database layer, you separate it to a data module. So you kind of have it there, and the data layer only knows how to do data-specific stuff, so networking and databases, which is, you don't couple it. So you decoupled it, and it's kind of its own thing. You can reuse it, in different modules. You can reuse it in different projects. Then you have the device-specific stuff, So that could be connectivity, that could be geofencing, something like that, which is also separate. So if you decide to use it in a different module, you can. If you don't need it, then you don't have to import it, right? And finally, the domain layer. So the domain is like clean data. So it's something that represents the data in the business logic layer. It's something that abstracts away the entities through interactors, repositories. And this kind of looks cleaner, right? So you come to the conclusion, okay, you've separated the code and everything's fine now, right? But not really, you kind of have this structure as again, but you decouple the code, but you decoupled it into layers. Again, if you want to go through the app and delete the login code, you have to go through 4 different modules. So you still have the problem again. Finally, in the last, excuse me, in the last, I don't know, a couple of months, year maybe, a new paradigm came, which is functionality-specific modularization dream project. Yeah, that's a mouthful. What it means is you take every single piece of functionality that can be separate and that can be reused, and you create a module out of it. So if you think about the networking, if you think about the database, you'd have networking module and a networking module, and you'd have a database module. Why is this better? It's because you can abstract away the base stuff away, and you can reuse it in different modules. And if you have a module which doesn't require a database, you don't have to import it, right? Which is, it's faster on the build time. It kind of looks like this. It looks a bit complex, maybe, but it's really not. You have the app module again, but you took everything out of it. So you took all the features, and each feature is now a separate module. But also you took out some base functionality. So for example, you have networking, which is now in a separate module, and you can use networking where you need it. So for example, on the splash screen, you don't need networking. You can use a local shared preferences flag to see if the user is logged in or not. So in Splash, you don't import networking, and it's it's faster for you to build Splash. Also, if you're working on a Splash module and you change something in the Gradle file or in the code in general, you only have to compile that bit. So you don't have to go through the entire app and compile everything, which kind of reduces your build time and quite a lot. So from a few minutes, you may come to under a minute, right? Which is really, really good in Android. Furthermore, there are things like Core and Core UI. So as I've talked about the core stuff, the base stuff, that's pretty much it. So the core module is the base classes, but not Android specific. So it's everything, you can abstract away the interfaces that you use in most modules, but they have no deal with the Android platform. Then you have the core UI. So that's the base part, but for Android. So base activities, base classes go here, base fragments. And of course, you have some things like preferences, networking and databases. So for example, if you were to go back to that problem of having the login code in your app and you want to remove it, you would literally just remove the login module and your code should work. So it's really decoupled now in a way that only the app module knows about everything. So it can build the dependency graph. But for example, if you're going from the splash screen to a login screen, you don't have to know about the login module. You can abstract away navigation in the app module and then just call an interface which has a method, for example, show login. The app does that logic because the app should handle navigation, and no other modules know about the navigation in that sense. So you kind of have this now. You separated things away, not in layers but in functionality. So if you were here to remove, for example, the blue chords, you would probably just kill a part of the feature. The rest should work, right? Additionally, you don't have to remove all the blue chords. You can just remove this one bit, and everything should work. It's really modularized. And the pros and cons. Of course, everything has pros and cons. The main pro, is the separation of concerns. So not only have you separated the structure, but also the code in general. So you can decouple everything. You can delete things as you go, or add things if you need them. And when you add things, you don't have to change anything else. So it follows the open-close principle, right? Furthermore, organization. Also, back to the point of finding login code. If you go to a login module, it has all the code you need for the login screen. You don't find it in the app module or the core module or something else. You just find it in the login module. So you can really browse through the tree of modules and find whatever you need. Of course, faster builds, because every single module has its own Gradle script, which compiles only a tiny bit of code. But it can be a bit complex. So you have to think about modules in advance. For example, when I first started off doing this, I had one single core module which had everything base, but it also had base activities and base fragments, so Android specific code. And then you come to the point, okay, I want to use something from the base, for example, coroutine setup in my networking, but I would implicitly, compile the Android runtime in the networking model, which is really bad. You shouldn't do that. So you come to the point when you have to look at the modules and see what you can split away, or what you should split away. And another problem is the dependency management. So in single app modules, in clean app modules, you have all the dependencies are handled in the app module, right? And you can start up everything, you know about everything, and that makes sense. But what about injecting stuff? So you have to have some API, like a component in Dagger, which gives you all the dependencies. How would you pass down that component from the app module to the feature modules? It's a bit hard, I do this through Coin, one of my favorite things in Kotlin and Android. There's going to be a really amazing talk about Coin led by Arnaud Giolani, and you should really check it out. I recommend it. I won't be talking about dependency management as much. So, we thought about the project structure, and everything makes sense now, somewhat. Let's tackle the configuration change. Configuration changes and memory management cannot go together. You can't have one without the other. So if you have configuration change, things reallocate. You have to clean the code that you're not using anymore. Otherwise, you're going to get a lot of memory leaks and a lot of RAM usage. So, I'm hoping you're not one of these people. You don't have to worry about leaks because you're not tracking them. But leaks are really important, because if you're constantly looking for them, and if you're constantly trying to optimize your code, it's gonna serve you better in the long run, as Yannis said today at his lecture. So optimizing dependencies has a few steps. So we kind of want to persist instances like the business logic, like the repository true config changes. We want to allocate them, once, so we can reuse them. So when we rotate a screen on Android and everything dies, the instances don't die. So just the UI recreates, right? And after I put it per screen session, because after we leave the screen, in full, then you have to deallocate it, right? You have to clean it up. So my team and I kind of came to this conclusion to create a scope retainer. So this would be a class which handles scoping of dependencies. But we immediately came to a problem of you have to build a scope retainer to retain dependencies, but you also have to retain the retainer, right? So it's kind of a backwards thing. We thought about how we're going to do this, and we came to view models and Coin again. So if you think about view models, once they are bound to a certain Android component, like the activity or the fragment, they persist through the orientation change. So our scope retainer is actually a view model, right? So we bind the view model using view model providers off to an activity or a fragment component, and we create a dependency management scope in Coin, attach it to the view model's lifecycle. And once the view model dies, we automatically clean it up. So this kind of sounds complex and everything, but in reality, it turns down to this. So this is a really simple class. We get the Coin context. This is like the general information about the dependency graph using Coin. We have the current scope, as a latent vars because we have to allocate it. This check is here, just so we don't try to recreate the same scope twice or multiple times. So once we create the scope, Coin starts up the dependency management of that scope. For example, login scope. So all the login dependencies will be started up, and of course, you can use the onClear function from the view model when the view model dies with the screen or so the activity or the fragment, and you can clear that scope. So the entire process of dependency management, memory management, optimization is done via one class. And in code, you would think it would be complex, but it's not. So you just create a scope retainer through the view model providers of. You check the saved instance state. Of course, if it's null, then we just came to the screen. If it's not null, then we have some state from our retention changes. And you initialize the scope with a getScope function. So getScope is just returns a string for that screen. So if it's, for example, login screen, we name it login scope. And this is everything that there is to dependency management and memory management. So we tackled configuration changes as well. People have been trying to do that for years now, and we just did it in a couple of minutes, right? So that's really cool. Another thing, or the last thing we have to do is improve our data flow. So one problem on Android is we have a lot of mutable state. We have a lot of checks around models. So if something is null or not, if there are present fields, so we can build better data structures and better data flow for these cases using functional programming paradigms like monads, and we can really improve our code, and we in a way that we always know what we have. So for example, we're gonna mix some functional programming and coroutines. We'll see how we'll handle the flow in a way that we want observable-like structures for the view states. So we want the view data to be emitted automatically, and we want that to be represented by one structure, which we can observe. We want to have a coroutine-driven entity layer. So all the networking, database reading and writing, it should all be powered by, well, at least we want to be powered by coroutines, because then we can have a really clean API, which we'll see a bit later on. And of course, monadic structures for data modeling. So there's a thing called result monad, where you have only two cases, and I'll just show it in a bit. First off, let's see how we're going to do the view state handling. So we have a state channel, which is a receive channel, which we send the data to. The UI subscribes to it and listens to the changes. We also have in the background, it's actually a broadcast channel, which with the conflated option, which kind of says, okay, I'm going to preserve the last state until you subscribe, and then when you subscribe, I'm gonna keep sending you the states. Also, we have a couple of helper functions with state and from state, where we can take the data and either use it or pass it on, or take a field from it without actually changing the data. So here we don't have the access to the state, because we don't want to tamper with it. We don't want it to be mutable, but we also kind of need to extract some fields and stuff. So we do it through helper functions. Don't mind the warnings. Also, we have a push view state function, which takes new state we get from the backend, pushes it to the stream, and then the UI gets a notification to render everything anew. Furthermore, for the asynchronous work, we have a couple of helper functions as well. So if you dug into coroutines a bit, and if you listen to Luis's talk on coroutines, there's a couple of functions which you can use. For example, the launch function, which creates a simple coroutine which just does some work. So it's a fire and forget, more or less. You have the async function, which works in the background, at least for us, and it receives a data provider function. So for example, this can be a call to the use case, which returns a user from the backend. We wouldn't really know how it gets to us because it's behind an API. So the idea here is to have an API and not worry about the context of the coroutines, not worry about which functions are being used, so we can abstract it away. And furthermore, we have like a cancellation mechanism for the jobs when the view model, or rather the presentation layer, is killed. Additionally, the result class. So you've probably seen this around. It's pretty common. So you use seal classes, which are called usually result or either or something like that, which are generic. And you have two cases. You have the case of a success and a case of a failure. So when you request for a user, you don't actually get a user. You get a result of the type user. So it can either be a successful case where you have the data, which is not null and is fully validated, or you can have the failure case which has an error, and then you can also handle that error. You can also write a couple of functions that help you do this, to have like an Rx-like code. Also, I built a mappable interface here. So if you have an API user or a user response model from the backend, it implements mappable, which gives a function if it's valid or not. So for example, if you have a user, it has to have an ID. And you have a function which maps it to the domain model. So when you actually get a user, it's either an error or it's fully valid. So you don't have to worry about that. And this entire layer is abstracted in the networking part. So it kind of looks like this. Also, it's a bit of a much. It's a bit much, but it's actually really simple. You have a try-catch block because we're calling execute. We're not using enqueue because coroutines, we can make them work in the background by default, while we use another background mechanism. So you can just call execute. Then you check the body of the response, and if it's valid, this is a API user or a user response, which is mappable. So we can check if it's valid. And if it is valid, we map it to a success case. Otherwise, we map it to a failure case. Also, we use the error result because this is all nullable, and we kind of have to do some null checking. If there is an error body, we probably got an error. So we just map it to a failure case. And then we return one or the other. Otherwise, in a catch block, so if something went wrong, like a networking exception, so we don't have internet, or maybe serialization or something like that, we get the excuse me, we get the catch block, and we just return the failure case. In our code, so in our business logic, we just have a simple function. We call execute, which kind of makes this run on the main thread. We can check the state, if we're loading or not to send too many requests. Then we say, okay, we get a data, and this is an example from the project. This is of type result of list of top rated games. So we get the data, we call the use case with the current page, and we get a result. So here we can check, if it's successful. That means the list is fully valid. It's not empty. It's not null. We can, process it later on and send it to the view state. If we got an error case, we can change the view state, of course, to is loading is false. And we can process that error somehow, so to see which type it is, what kind of codes it has, and we can, show some messages. So in my talk, or at least the title, I mentioned Rx. So where does Rx fit in? Well, I use channels for the view state, transfer and broadcasting, but you can use Rx there if you prefer that. You can use some different operatives. You can use things like, this thing to not send to the same events. You can also use Rx to, when you abstract away the networking layer, you can use Rx to build some kind of caching mechanisms for the data sources. So when you're requesting for the user with the same parameters, things probably didn't change, so you can just retrieve the user from the cache rather than having to request a new API call. And pretty much, it's not exclusive. So Rx versus coroutines is not exclusive. You can have one or the other, or you can have a mix of both. For the most part, I think you're good with coroutines because of networking requests. They are just a single value. And if if you want to have some caching mechanisms, so uniform that data flow, you can use Rx. So you're probably thinking, why would you do all these things? So to start off, why would you modularize? Well, you're preparing your code for things like instant apps and dynamic delivery. I don't know if you heard about that. So instant apps are, well, they've been out for a while. So it's a way of, just installing one module, one screen, when you get a deep link or something like that. So you don't have to download the entire application, you just get one screen. Dynamic delivery is similar, but it kind of requires of you to have the core app, and then you download modules as you go. So you can't do this with a single module because you have to download everything at once. That doesn't make sense both for instant apps and dynamic delivery. Furthermore, you speed up the Gradle process. You organize your code, you organize your dependencies, and if you need to include a lot of things in a new feature module, you just compile the core modules or the core UI modules, and you have everything ready. If you do need something special, then you just add a dependency. And of course, you abstract things away, you decouple the modules, so you can delete everything if you don't need it, or you can reuse stuff without actually knowing what's in the background. So it all follows clean code. So why would you use view models? Well, they simplify the scoping mechanism for you. Rather than building an entire API around that, you can just use a simple view model and a scope retainer class, which I showed. You have seamless orientation and configuration changes because you persist the entire dependency graph for that screen. And when you rotate, you just subscribe to the data and get the last data you had. What about coroutines and functional programming? So I didn't show a lot of functional programming stuff. Coroutines by default are kind of more functional than OP, but it in turn gives you readable code, which is sequential. It's easier to reason about sequential code rather than callbacks and Rx. And you have nearly no cognitive load because you say, okay, I want to get some data, I want to get a user, and you get it, and you can use it later on. You don't have to do callback hells or Rx operators. Also, you have explicit bridging between the UI and the background, which you might not have with callbacks. So sometimes you might, mess something up. Or if you're using Rx, it's not always clear what is in the background and what is in the main thread. Yeah, because you can have multiple subscribe bonds and one single observe one, and it can shift between threads. And you have clean types. So the result, when you get a result, it's either a failure or a success. You can't have some case which you didn't cover. You don't have any edge cases. And you have some state machines, processing, because you can switch on that result, check its type, and if it's of type success, then you have the data. And you can do more here, so you can abstract away more cases to have it like a success, a failure maybe for no connection, a failure for something was wrong with the backend, and so on and so forth. And the key points I'd like you to take from here is when you organize and decouple your code, it makes your life it makes your life easier because you don't have to work with legacy code and you don't have to dig around through everything to find something you're looking for. So if you have a new programmer on the team and he has to build, for example, a registration module, he doesn't have to suffer that load of going through the entire app. He just has to create a registration module and work on that. You shouldn't be afraid to experiment. So most of the things here I showed, I used before 1.0. For example, I've been using Coin since 0.4, I think. Coroutines are still not 1.0. They are stable, but they're not done yet. Also Kotlin, you should be using it if you aren't already. So all these things are kind of experimental. They're kind of new, but you shouldn't be afraid to experiment with them because you can really come up with amazing solutions which simplify your life, which you couldn't do before. And of course, everything can be simplified. So when you think about anything in your app, for example, dependency management or retention changes, you can simplify that. It just takes a bit of effort, maybe an open mind to think how you can program it differently, just like with the scope retainers. And of course, leverage Kotlin's language features. So things like coroutines, like extension functions, lambdas, you should really try to leverage that as much as you can. And you should try to use seal classes as well, for example, for state machines. And I think that's pretty much it. You can check out the project I'm working on. So these slides and these examples were from my personal project on GitHub. It's open, and I really invite every one of you to take a look. Maybe go through the code and give me some feedback. Or if you want to work on it, you can do that as well. I can add you as a contributor. The idea is to have just a lot of ideas and a lot of things tested out. So we see how things go. For example, with Coin, I tried to tinker with it a bit, and then my colleagues from work and I took that project, and we tried to think of a better way to scope stuff. And you can also check out my article about building a generic networking layer in Kotlin or in Android using Kotlin. Are there any questions? 1 second, sorry. If you ask me a question, just ping me directly on Twitter, so direct message, because I have 2 books to give away from Ray Wennerly about Kotlin, so Kotlin Apprentice, and Android Apprentice, which is Android in Kotlin. Also, you might have noticed all the stickers here, so they're up for grabs. You can take as many as you want. And yeah, so go with the questions now.
In the company you work for, how big is the team that works on this application?
So the project I shown was a pet project, so we kind of all try to look at it and give some feedback. But we're trying modularization, we're trying coin and scoping on a couple of other projects. There's 11 of us currently, so we kind of all gather weekly and go about the ideas and everything to see if we come up with something that's even better. So it's like a weekly process, and there's 11 of us, so there's a lot of minds, different mindsets to look at the code.
It's about modularization you mentioned at the beginning, because you were showing how to separate, in particular, database module and some kind of features. And I wonder, what do you actually put in this database module? Because when you make it, you want to reuse it in multiple projects, right?
Okay.
So you cannot put there any specific entities or DEAs objects. So you put these in specific features. But what exactly do you put in database module? How do you reuse it?
Sorry. Okay, so that's a really good question. It comes down to how abstract you want it to be. So if you have a database module which you want to reuse on maybe other projects or something like that, you can put all the basic stuff. So if you're using Room, for example, you can build the Room abstract Room database, and you can export it away, or rather make it public. So when a module, for example, the login module, imports database, it can define different entities. You can define a table or a DAO in Room, and then you can just use that database to build the DAO. You can pass the entity name, the table name to the database, and build it that way. So you kind of don't depend on the database to build everything. You just depend on it to give the basic interface away, and then you take it and build the same, build whatever you want. So it's kind of the same with networking. So the networking module doesn't actually contain any API services. It just provides you with the retrofit, client. And then if you have, for example, login, it imports networking, and it builds its own login API service using that retrofit client.
Okay, could you please say once again how you would do this with Room in particular? Because you put their entities in annotation, and similarly you do it with DAOs.
Yeah, so it's kind of hard now. You should be able to build a DAO and entities that are connected with the DAO in the feature modules, and then pass or rather use the database abstract database to build those not entities but DAOs. Kind of thinking about it, you can abstract it away in a maybe core something that's a bit base. For example, if you have login, you can have something called login base, and you can have maybe a subclass of the database which takes in the entity for login. So you can then import that. So you can do it through hierarchy. So composition. Sorry, not composition, but rather subclassing. Yeah, my bad. Okay. Yeah, sorry. Mugs for you and for you. Can we give them away? Yeah. Any other questions?
I've been thinking, you were at my presentation and you were talking to me about the cohesion between the modules. Yeah, coincidentally, we had the same topic. So, where do you store shared state? So, for example, you have a login module, which is completely separated from the other modules. But something like, in my case, a timeline or a chat message would be dependent on other knowledge, like tokens or whatever. Where do you store that? Do you do that in a config file that's like a singleton within core, or what's the...
Do you mean just defining the states, for example, entities, or do you mean like actually storing them? So
Well, there is one part where, let's say you have a module like a chat and a relation from the chat to a user profile, which might be a separate module. They share a lot of common data types. So do you store the models, for example, in the module that, that deals with it, like a chat message within the chat? Or where do the boundaries start and end?
okay, so it's a really interesting question as well. So an example I actually thought about when thinking about that is you have the feed and you have feed details. And when you press an item, you have to go to the feed details. But you might not want to send an ID just to request everything again. You wouldn't want to have two different models, which are, or rather two different classes which are the same model. So you can have, if you're in the case of feed and feed details, you can have like a feed-based module which has that model defined, and then both feed and feed details can import it. So feed knows about the feed model, sorry. And feed details knows about the feed model because of the base module behind, and then you can pass away the model. And then again, if you need it on a third screen, it's gonna include that as well. So you can have like a small module which just defines models, and you import it like that. Otherwise, it's pretty difficult because they are not supposed to know about each other, but they kind of do, So yeah.
So you've talked about vModel class and how it can help with orientation change. But how can you deal with a situation when a system kills our process and then your viewModel is cleared, but save instance state is not null?
Okay, that's a really interesting question. I haven't actually gotten to that case, so I'm not sure if I can answer it properly. But then again, if the same instance state is not null, yeah, you kind of have to depend on the scope being ready, but it's not, right? So everything will be cleaned up. Maybe you can check, well, you can check the retainer as well. If it's initialized or its scope is not initialized, that means everything recreated, but it's still kind of, it died, but it didn't, And you can check the scope ID or whatever you store. If it's initialized, then everything's fine, you have everything. But if you come to the case where saved instance state is not null, but it's not initialized, then you can force it to initialize again. So I kind of did the basic case here. So if you've got null in saved instance state, then just initialize. But you could do better checks around that. So yeah, that's a really good improvement, and I actually write that down. So yeah, if you have a saved instance state, then you can have another check with the retainer to see if the scope is initialized. If it is, then do nothing. If it's not, then you have to force the initialization. Yeah.
Hi, I would like to ask about that scope retainer because it extends viewModel. So basically, you're creating one scope retainer for each fragment or each activity, yes, and you're not unit testing it, yes, because it would be very hard to test it.
Yeah, it's really hard to test it, but then again, there's not much to test, I guess, other than the scope being active and things not falling apart. So a good test I guess, would be that if you run the screen, if you're writing integration tests or UI tests, if everything goes well, then the scope is built. You can do checks around the initialization of the scope. If that fails, then obviously something's wrong. So you have to dig deeper to see where the setup failed. And that's a good question. We haven't really gone to the part of testing it. So the retainer itself is actually a few days old. So we kind of went back through all the code, and we thought about how can we improve it. So we came up with it this week. I'm not sure, Monday or Tuesday, something like that. And yeah, thinking about that, it was way better than before. What we did. So we used, or at least I used to just if I have the business logic, I just made it a view model as well. So rather than persisting the scope, I persisted the business layer, which is kind of bad. Yeah, it's really bad. So this is next step, or a bigger level of abstraction. So you just create a scope and you persist the dependencies, or rather the scope, and when you request them again, they should be alive. So yeah, that's a good question, and I'll see about that and maybe write a blog post or something. Yeah. Anything else? Nothing? Okay, thank you for the awesome audience.